Hello students, and welcome to 2.2 part B of this section. What we're going to be doing in this section is, in our previous video, we were looking at the graphical representation and what that meaning was. We're going to now extend that idea to numerical reasoning when we're just given values of points in a table. Let's get started. So what I can do to find the estimation of the derivative in this case when I'm just given a table like what we have above, what I can do is I can actually take the values that I have. So if I want to find it at 0, for example, all I need to do is take the values to either side of it, the x and the y values. What I'll do is I'll do like y2 minus y1 and x2 minus x1 and find that secant line that's connecting those 2 points around it. So let's go ahead, see what that looks like. So that's going to be -3 minus 2. Actually, let me change that real quick. So we're going to say f prime of 0 is -3 minus 2 over 1 plus 3. So that 1 and -3 and that -3 and 2 point as well. So then, okay, what do we get? I get -5 over 4. Well, what we learned is that when my derivative is negative, well, what is that saying? Is that increasing, decreasing, a relative max or a relative minimum? Well, since it's negative, my function is decreasing. Let's see if I can go ahead now and find the equation, the tangent line at this value of x. Well, since I have 0, I know that the point of tangency right here, my point of tangency is going to be 0, 1. And we have a slope that I can use, -5 over 4. So I'm going to have y minus 1 equals -5 over 4 times x minus 0 in this case. And that could be my equation for the tangent line at the value of x. All right, going a little bit further down to when my x value is 1. Well, what we'll say is f prime of 1 is equal to 0 minus 1 over 4 minus 0. And so what I'm going to get is -1 over 4. And again, is my function increasing or decreasing? Well, since it's negative, my function is decreasing. All right, so let's determine what's the point of tangency. Well, the point of tangency is going to be 1, -3. Just grab that straight from that table, 1, -3. And so when I set up my equation, that's going to be y plus 3 equals -1/4 times x minus 1. All right, let's keep going a little bit. So here in x equal to 4, let's find f prime of 4. Well, what are we going to get with that? That's going to be -7 plus 3 over 6 minus 1. All right, so that's going to get me -4 over 5. Since it's negative, my function is going to be decreasing, just like that. And my point of tangency is going to be x equal to 4 and y equal to 0. Again, just grabbing that value from my table. And so when I write out this, it's going to be y minus 0 equals -4/5 x minus 4. Just like that. Now let's look at 6. Well, what do we get with f prime of 6? Well, that will come out to be 2 minus 0 over 10 minus 4. Well, what do I get with that? I get 2 over 6, and that can simplify to be 1/3. All right, so positive 1/3, what I notice is that that's increasing. All right, so what is the point of tangency here? Well, my point of tangency here is going to be 6, -7. We're going to use those points to write my function. So the equation of the tangent line is going to be y plus 7 equals 1/3, my slope, x minus 6. Well, now let's continue to build on our idea of increasing and decreasing function from graphs. In this case, I want to find the intervals where g prime of x is less than 0. So right here, I have g of x. So I want to find where g prime of x is less than 0. So g prime of x is where the graph of g of x is decreasing. So function decreasing, derivative negative. Okay? So where's my equation decreasing? So that's going to be here and also right there. So how am I going to write this? What's going to be my justification? Well, we're going to say g prime of x is less than 0 on, what we're going to do is give those intervals. So here I have from -4 to -2. And union, I have it from 1 all the way to positive infinity. So those are the sections where the function's decreasing. What are we going to say? The reason for that is because the graph of g of x is decreasing. So the stimulus that we're given is our function g of x here. So what I can say is I want to include that in my justification. I know g prime of x is going to be negative on those intervals, -4 to 2 and 1 to infinity, because g of x is decreasing. That was my stimulus, so I include it in my response. Now I want to find the intervals where g prime of x is greater than 0. So again, I'm thinking, all right, greater than 0, where the derivative is greater than 0, what's the function doing? The function's increasing. So the areas where my function's increasing are right there and right there. So I know that g prime of x is greater than 0 on the intervals -infinity to -4 union -2, 1. The reason I know that is because the graph of g of x is increasing. Again, I'm using the stimulus that I have g of x in order to write my justification about g prime. Now I want to figure out where the values of g prime of x are 0. Those are where we had relative extrema, maximums and minimums. So where do I have maximums and minimums? Well, I've got one here, I've got one here at -2, and I've got one up here at +1. So we're going to say g prime of x equals 0 when x equals -4, x equals -2, or x equals 1. At all of those points, g prime of x is equal to 0. Well, what we're going to say now is because g of x has a relative maximum or a relative minimum. That's going to conclude this part of section 2.2. We have one more video, the next part, where we're going to go over the normal line. If you're still struggling with this concept of increasing and decreasing and that relationship with maximums and minimums in terms of the derivative, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.